Okay, hello and welcome. I'm Travis McEwen, and we are going to be going over just a little bit of Lab 9 just to kind of get everyone started a little bit. So I've had a few questions already on this, so I figured I would just go ahead and make a short video to kind of go over this. So what we're going to do is we're going to talk a little bit about subnetting, and what we're going to do in this video is walk through the subnetting for each of our networks right here. So the first thing to note and kind of talk about is when we're looking at subnetting, remember we're creating and subnetting for these different individual LANs that exist on this topology. So what I'm kind of highlighting right here are the actual different LANs. So we have our first LAN, which is for our PC1 going up to router 1 there. Our next one is for PC2, and that's 60 hosts. And our third is for PC3 right here. And so what we're going to do is we're going to talk about how to actually subnet out and kind of create the networks for each of these. So this kind of gets us into remembering us talking in my prior video a little bit about how addressing works. So what we have right now is we're starting with a initial starting point of 172.16.0.0/24. And so what that essentially is really doing for us here is we have to think about that in the scope of what does this actually mean. So if I have 172.16.0.0/24, remember what this is telling us is that this /24 means that the 172 is locked in place, the 16 is locked in place, and that third that 0 is locked in place. So I can't do anything with these first 3 octets. So all 8 bits in each of these octets, so the first 24 bits are locked in place, but that last octet is free and available for me to kind of manipulate and utilize. So what does that mean? Well, in this 4th octet, we have a total of 256 IP addresses that exist. Not all of them are usable, but there are 256 in all. So what we're doing when we're subnetting is we're dividing this block of 256 into different chunks, into different even chunks. So if I have, say, some try and get rid of that real fast. That's fine. So what we're essentially doing is we're creating this initial block of 256. So I'm starting with 256 IP addresses. And what we're doing is we're going to be dividing this up into different categories. And now we have different ways that we can divide this up. Now I can divide it in half into 2 even blocks of 128. I could divide it into different chunks as well. And sorry, this decided to just change something really here. So I could divide it into multiple different chunks of, say, blocks of 64. So each of these are different ways that I can do it, and I could, divide it into, 8 blocks of 32 or so on and so forth. And with subnetting, we can divide it up into different even sections as well. And so we could do like a block of 128 and then say 2 blocks is 64. And so that's what we're doing when we're subnetting, is we're taking this initial starting point of 256 and dividing it out. So to kind of walk through this a little bit better, we're going to look at, say, setting up our a little sheet, and I'm just using Excel just to make it a little bit easier here. And in the sheet, we're going to walk through actually configuring and setting up our different networks for subnet. So again, our starting point is 172.16.0.0/24. Now, again, what this /24 is representing is it's a shorthand way of writing out our subnet mask. So remember, this is our subnet mask here. Now, again, how we're getting this and how this represents that /24 is, remember that in each of these 4 parts, they're typically separated by a period, but it's Excel. There are a total of 8 bits inside of them. Each of these 8 bits has a numeric representation of 1, 2, 4, 8, 16, 32, 64, and 128. Doesn't matter which octet I'm in, that numeric representation in this number chart is the exact same. So each of these 8 bits has the exact same numeric representation. Well, what we mean by saying that this is a /24 is this is where the binary kind of comes into play, where 1 is equal to on, or it's being used, and 2 is equal to 0, or off. So 0, is equal to off, or it's not being used, and it's free and available to be manipulated. So in this case, when I say that, we see that 255, it means that all 8 bits are in an on state. They're currently being used. And so if you add up all of these 8 bits, we get 255. So this right here, this /24 is stating that the first 3 octets are locked in place and I can't use them. It means 8, the first octet, all 8 bits are turned on. The second octet, all 8 bits are turned on. That gives us 16. And in the third octet, all 8 bits are turned on. And so that gives us 24. 8 plus 8 plus 8. But the fourth octet is free and available to us, and that's what that 0 represents. It means that in that last octet, all 8 bits are off, and I can still manipulate them. So for actually subnetting, and what we're doing in this lab is we have 3 networks that we're creating. We're creating a network for 120 hosts, a network for 60 hosts, and a network for 12 hosts. So let's walk through how we can kind of do this. So what I like to do is write out this little kind of chart of information. So I have my network, my first usable IP address, my last usable IP address, my broadcast, my mask, my CIDR notation, and also the number of hosts. So what we're going to do here, sorry, one second. What we're going to do here is we're going to list out all the information that we have right here. Sorry, the dog was deciding to join and be a little annoying there for a second. So network 1 are always going to be our absolute starting point. So it's always going to be 0. So in this case, our first network is just, where do we start? Well, we start at 0. Now, the first usable is we're just adding 1 to the current to our 4th octet. So it's the very first IP address. So we're adding 1 to that last 0 right there. So our first usable IP address is 172.16.0.1. Okay, so now that we have that information, the next thing that I like to do is to start utilizing this number chart to figure out where our next network is going to be, and that will help me fill out my last and broadcast. So how do we do this? So we're going to we know we need to supply for 120 hosts. Well, we have this number chart available to us. When we're subnetting, an easy way to subnet, and this uses pretty much what's considered the magic number method, is to take that number and go, where does 120 fall in this network, in this subnet chart? Well, 120 falls in between the 64 and 128. So now what I would do is if I was writing this out on, say, like a piece of paper or a whiteboard, I'd draw a line right here in between the 64 and the 128. Now, since this is Excel, I can't do that. But what I'll do is we'll mark in red and the bit, one bit, and then we'll mark in green the others. So what we're going to do is we're going to actually say, we're going to go through this and we're going to say, okay, well, which bit is this line that we've kind of set up defines whether we have which bits are turned on and which bits are turned off. Now, the 128 flips to a 1, and remember we have that imaginary line, and everything to the right in between here is still left at zeros or still left as green. So this is essentially what we're defining here. So this now becomes our network bits, and these are our host bits. So in order to figure out where our network 2 is going to be, we're going to take this number that is directly to the left of our imaginary line here, between the 128 and the 64, and we're going to add it to our current network and our current octet. We're working on the fourth octet, and that'll tell us where our next network is going to be. So we're adding 128 to the 0 in the fourth octet of network 1. So our next network would be at 172.16.0.128. So now that we have that, it makes it pretty simple to figure out our broadcast and our last usable. Our broadcast is just one less than the next network. So it's 172.16.0.127. And our last usable is just one less than the broadcast, which is 172.16.0.126. Now, the important things to kind of note here is that we have this is our range in network 1. So this is essentially what we're stating here when we define that line in between the 128 and the 64, is that this number directly to the left of the line of our imaginary line here, this 128, is essentially determining our block size. So what we've just divided that 256 up into is we've now divided it into 2 blocks of 128, and network 1 here is using that first block of 128. So I have another block of 128 IP addresses free and available to me left over that I can divide up into different ways. So moving from there, we can figure out our mask and our CIDR and also the number of hosts that are available to me. So our mask here is going to be 255, 255, 255, because that's our first 3 right there. And then we're adding up the bits that we flipped to an on state, which is just that 128. So in this case, our mask is 255, 255, 255, 128. Our CIDR or also known as slash notation there, is going to be we're counting the bits that we've turned on. Now we're starting from a block of /24 because the first 24 bits are all flipped on. So we've just flipped on the 25th bit. So another way of writing out this mask in shorthand is just to say it's a /25. Now for the number of hosts that are available to me, this is again where this number chart comes in handy. And this number to the left of the line, this 128, we're going to just subtract 2 from it. And that gives us our number of hosts. That's 126. Now we subtract 2 because we're subtracting the network IP address, and we're also subtracting the broadcast address because these two addresses are not usable addresses. I can't assign 0.0 to an interface or to a PC. It's just a representation of the network. And I can't assign the 127 out because that's the broadcast. All devices on this LAN, this network, can use that 127. So that's a shared address. So that leaves me with a total of 126 IP addresses. So moving on to the next network, we have network 2 here. We're going to find for 60 hosts. So we're going to figure out where 60 falls. 60 falls in between the 64 and the 32. So this would mean that we're drawing our line in between the 64 and the 32. So we're turning on the 128 and the 64-bit. So now that we have that, a couple things that we can do. Our first usable is we're just adding 1 to that current network. So 129. And then where network 3 is going to be is we're adding the number directly to the left of our line where we've kind of drawn in between the 64 and 32. That last red number right there. We're adding it to our current network, and that'll tell us where network 3 is. So we're adding the 64 to the 128, our current network and current octet we're working on. And so network 3 would start at 172.16.0, and 128 plus 64 is 192. So my next network is going to start at 192. So then we're going to list out our last usable in our broadcast. So again, our broadcast is just 1 less than where network 3 is. So it'd be 172.16.0.191. And our last usable is 172.16.0.190. Then we'll find our mask. So again, 255, 255, 255. And then we're adding up the bits that we've turned on. So 128 plus 64 is 192. And then our CIDR or slash notation, again, we're starting still at a block of 24. We're just counting up the bits that we've turned on since then. So turned on the 25th bit and we turned on the 26th bit. So another way of saying 255, 255, 255, 192 is to say a /26. And then number of hosts that we're providing for, again, take the number directly to the left of our line, our imaginary line in between the 64 and 32. So the last bit that we've turned on, and we subtract 2 from it. And so that'd be 62. And remember, we're subtracting 2 because we can't use the network address and we cannot use the broadcast address to assign out to individual systems. So last one that we're going to do is network 3. So first usable, nice and easy to fill out, just add 1. So first usable in this network would be 183. And then we don't have a network for in our topology that we're going to be using, but we're going to go ahead and just write it out here. So in order to figure this out, again, we're going to be working with, we need to find where a network that's going to be able to supply for at least 12 hosts. So 12 is going to fall in between our 16 and our 8. So that means, again, we're turning on the 32 and the 16 there. And the last bit that we turned on is what we're adding to network 3 here. So if we add 16 to 192, our next network would be at 172.16.0.208. So now that we know that if I had a network 4 where it would start, my broadcast is just one less than that. So it would be 0.207. And my last usable would be 206. And same thing for adding up the mask. We're just adding up all the numbers that we've turned on, so the 128, the 64, the 32, and the 16. So that would be a mask of 240. Our CIDR, again, we're counting up from the 24, so the 128 would be the 25th bit, 26, 27, 28. So we've turned on up to the 28th bit. And then the number of hosts that we're supplying for, the last bit that we've turned on, that's 16, subtract 2 from it, we have 14. And so that's our, remember, we can't use the network address or the broadcast. So now that we have that information, it makes it fairly easy to kind of go over and be like, okay, well, where are we kind of labeling things? Well, in this packet tracer, I've given you kind of the addressing schema of what your system should be. So the first usable IP address for, say, router 1 should be 172.16.0.1. The PC should get the last usable IP address, which we now know is 172.16.0.126. And then if we go over to our other network, the first usable IP address for network 2 and PC2 right here should be 172.16.0.129. The PC gets the last usable IP address, which is 190. And then network 3 here gets 172.16.0.193. And our PC gets the last usable, which is 206. So that's what we have for these. Now, the one thing to remember here when we're configuring this and when you're actually setting our static addresses, remember that you're setting up the 126 there. You are configuring the mask, and then you do need to remember to set your default gateway. And remember, your default gateway is the router. So it's the doorway out of your LAN. So if PC1 wants to leave its network, it has to send traffic up to the router. And so the furthest point it knows or can see is that G01 interface on router 1. So that is my default gateway. It says if I want to leave my network, send the traffic to the router at 172.16.0.1. Now for PC2, its default gateway is going to be a little bit different. So remember, each LAN has its own individual default gateway, its own doorway to leave its network. So for network 2, we have 172.16.0. It wants the last usable, which would be 190, and then our mask of 192. And then the default gateway is router 2's gigabit 01, which is the first usable IP address in network 2 there. So that IP is 172.16.0.129. So hopefully that was a little helpful for kind of going over subnetting as a whole. I'll pull up this chart one more time. So again, these are your networks that you're creating and subnetting out. If you do have questions on subnetting, again, feel free to reach out at any point in time. All right, thank you.